So in my first video for the extra problems, I went over I gave you the answers to all the problems, and then I went over how to do questions 1 through 3. Now I'm going to pick it up here with question 4. We'll see how we go. If I start to run long again, I'll make another part, which is a good possibility since there are 11 questions. So starting back up with question 4 here. For part A, it says, what is the mass in grams of 0.0387 moles of N2O4? So this is 4A. The first thing I'm going to do is write down what I know. I know that I have 0.0387 moles of N2O4. And I want to get to mass. So I know that 1 mole of N2O4 has a molar mass. Now, we calculated this way back at number 1 here, okay? Has 92.02 grams of N2O4. My moles cancel. When I do my multiplication, I get 3.56 grams of N2O4. Okay. For B, we're going back to that sodium sulfate decahydrate. And they're reminding you to include the hydrate in calculating the molar mass. So I want to know the mass of 5.41 times 10 to the 26 formula units of this compound. So I start out with what I know, those formula units, 5.41 times 10 to the 26 units of this compound. Nah, I'm getting a little messy here. Hopefully you can read that. I have to get from formula units to moles. So I know that there are 6.022 times 10 to the 23rd units of this. And 1 mole. Now I'm going to have to extend this like I did before. I'm running out of room. So my units cancel out. I have 1 mole. Of the compound. Now I have not calculated the molar mass of this before, so I'm going to go down here and figure out that molar mass. So I have 2 sodiums, so it's 2 times 22.99 grams from my periodic table. I have 1 sulfur, which is 32.07 grams. Now be careful with your oxygens because I have 4 here, but I have 10 here because I have to multiply by the coefficient out front. So I have a total of 14 oxygens. So 14 times 16.00 grams. And then I have 20 hydrogens because it's 10 times 2. So 20 hydrogens at 1.008 grams. So when I multiply and add all of that up, I have 322.2 grams of this in 1 mole. And so I put that up top here. When I do the multiplication off the top and divide it by what is on the bottom, excuse me, I get 2.89 times 10 to the 5th grams of Na2SO4 decahydrate. Okay, I'm going to switch to another paper for part C. And for 4C, I am asked, what is the mass in grams of 2.51 times 10 to the 23rd formula units of NH4 to C2O4 hydrate, monohydrate? So I start out with my 2.51 times 10 to the 23rd units of this compound. We're going to run out of room fast on this one, aren't we? I need to convert to moles, and I know that I'm going to need Avogadro's number here, so that goes on the bottom. I'm going to run out of room for this compound's name. Is 1 mole. Okay, we're going to have to extend this down here. Now, I'm into moles. I need to get to mass, so I'm going to need the molar mass of this. So 1 mole H4,2C2O4 monohydrate. Now down here, let's calculate the molar mass. Okay, so 2 nitrogens, because there's a 2 outside of the parentheses here. So 2 times 14.01 grams from my periodic table, plus, now hydrogens, I have 2 times 4, which is 8 here, but I have 2 from my water as well. So that's 10 times 1.008 grams. Carbon, 2 of those, so 2 times 12.01 grams. And oxygens, I have 4 here, 1 here, for a total of 5 times 16.00 grams. So when I do all of the arithmetic, I get 142.1 grams. So I go back up here, plug that in. And when I multiply across the top, don't forget I have it divided here, divide by what's on the bottom, I get 59.2 grams of NH4,2C2O4 monohydrate. So that is 4C. Let's go on to 5. So for problem 5, I'm given vitamin E occurs naturally in vegetable oil, where it acts as an antioxidant. That's really noisy to me. Some people take a half a gram of vitamin E daily as a nutritional supplement. Each 0.500 grams contains 0.404 grams of carbon, 0.0585 grams of hydrogen, and 0.0372 grams of oxygen. What is the percent composition of vitamin E? Remember, for these problems with percents, this is always part over the whole times 100. So part over the whole times 100%. For carbon, we are given that the amount of carbon is 0.404 grams. The whole thing is 0.500 grams times 100. So when we do that math, we get 80.8%. Remember, 3 significant digits here have to end up with 3 significant digits there. For hydrogen, I'm given that the mass of hydrogen in this sample is 0.585 grams. Divide that by the total, which is 0.500 grams, times 100%, and I get 11.7% hydrogen. For the oxygen, 0.0372 grams of oxygen over the whole thing, which is 0.500 grams times 100, and I have 7.44% oxygen. Okay, remember, keeping the 3 significant digits the whole time in my answers, because I start out with 3. Going on to 6. The question says, dinitrogen monoxide, commonly called nitrous oxide or laughing gas, was once commonly used as an anesthetic. N2O is 63.65% nitrogen. What mass of N2O contains 4.850 grams of nitrogen? Okay, for this I'm going to set up a proportion, because I know that 65% can be put over 100, and this means that it's a proportion. There will be 63.65 grams of nitrogen in 100 grams of N2O, in laughing gas. So if I go over here and I know that I have 4.850 grams of nitrogen, I can put that over X to figure out what my mass of laughing gas is of the nitrous oxide. So I cross multiply. 63.65x equals 485.0, because it's 100 times my 4.850. Divide both sides by 63.65. And X is 7.620 grams of nitrous oxide. Remember, I have 4 significant digits here. I have to end up with 4 significant digits here. We don't count the 100 because that is an absolute number. Okay, let's go on to number 7. And the question states, manganese 2 acetate is used to make dyes permanent. Manganese 2 acetate is 27.8% carbon, 3.50% hydrogen, and 37.0% oxygen. What mass of manganese is found in 125 grams of manganese 2 acetate? So they give me the percentages of everything but the manganese, so I have to figure out the percentage of manganese. So the percent of manganese is 100% minus the percentage of all the other ones added up. So it's minus the 27.8% for the carbon, minus the 3.5% for the hydrogen, minus the 37.0% from the oxygen. And when I subtract those out of 100, I get 31.7% manganese. From there, it's just like the previous problem that we just did. We set up a proportion because I know that if there are 31.7 grams of manganese and 100 grams of manganese, then I can figure out the amount of manganese in 125 grams. So I cross multiply. 100x is 31.7 times 125. Divide each side by 100. And when I do that and do my multiplication and division, I get that x is 39.6 grams of manganese and 125 grams of manganese 2 acetate, I believe it was. Okay. Going on to problem 8. Many aspirin substitutes in the United States contain acetaminophen as the active ingredient. Acetaminophen is 63.56% carbon, 6% hydrogen, 9.27% nitrogen, and 21.17% oxygen. What is the empirical formula for acetaminophen? Okay, remember for these problems, first we're going to convert to moles. So I am going to just change my percentages into grams. So instead of writing them as percentages, I'm going to write them as grams. So I have 63.56 grams of carbon. And from my periodic table, when I look at the mass for carbon, I know that the molar mass is 12.01 grams of carbon is 1 mole of carbon. And I'm converting to moles because in my formulas, the subscripts can stand for moles. They stand for either number of atoms or number of moles. So that's why I'm converting to moles. And so when I do that division, I get 5.292 moles of carbon. Now remember, 4 significant digits, 4 significant digits. When I do my next one for the hydrogen, I have 6 grams of hydrogen, just converting that percentage to mass. Now from my periodic table, I know that there are 1.008 grams of hydrogen and 1 mole of hydrogen. Do my division and I get 5.95 moles of hydrogen. Going down here, let's go to the nitrogen. So 9.27 grams of nitrogen. From my periodic table, 14.01 grams of nitrogen are in 1 mole of nitrogen. Doing my division, I get 0.662 moles of nitrogen. And last but not least, I have my oxygen. So I have 21.17 grams of oxygen. Oxygen has a molar mass of 16. Remember, I should be canceling all these out and moving this up so you can still see it. So when I do my division, I get 1.323 moles of oxygen. Now, for empirical formulas, now that I'm in moles, I go through and I divide everything by my smallest number. So I'm going to divide my 5.292 by 0.662. So 5.292 divided by 0.662. When we round that off, ends up being about 8. 5.95 divided by 0.662, because remember, we're looking for nice round numbers here. When I divide that, I end up with about 9. Now 0.662 divided by 0.662 is obviously 1. And 1.323 divided by 0.662 is 2, rounded off. So I end up with the formula. Whoops, sorry, got cut off there. I end up with the formula C8H9 N with nothing behind it, O2, because it's a 1. Okay, so that is my empirical formula. I'm going to cut the video off here, and I am going to do 9 through 11 on another video. So I'll be back in a few minutes.